What's good, y'all? This is probably the last video today, bro. Anyways, man, I wasn't gonna watch some shit like this, bro, because I thought it was gonna be too way out of there, bro. But I guess I'm gonna just do it, bro, because that last two videos we just watched, bro, I think it's only right that we watch this shit right here, bro. So basically, we're gonna watch scientists reveal how time travel is actually possible, bro.
There are two ways you can travel through time. You could go forward or you could go back. The crazy thing is, there are people traveling forward in time as you watch this video. Traveling to the past can be a bit more tricky due to the universe-ending paradoxes, but new research suggests time travel in both directions is not only possible but safe as well. The question is, would you do it? At the most basic level, time travel is about speed, space, and gravity. For example, a second for someone standing on Earth will be different than a second for someone who is moving close to the speed of light or near a black hole. And although we don't have the technology to go that fast yet, according to mathematics and science, this is how time works. We can even observe time shifts in action above our world right now, as time travelers whiz by at 17,130 miles per hour. Where are these intrepid explorers of time, you might ask? On the International Space Station. That's right, flying above your head right now is the crew of the ISS, and they are technically traveling both through time and space. The reason for this is that they're moving much faster than we are here on Earth. The faster someone is moving, the slower time goes for them relative to someone who's standing still or moving slowly. This is just how the universe works. Therefore, the astronauts on the International Space Station are experiencing time slightly slower than you are on Earth. To be fair, not much slower, but it's still happening. Scott and Mark Kelly are both astronauts for NASA. They're also identical twins. However, Scott has spent 520 days in orbit, while Mark has only logged 54 days in space. Since they're identical,
Can we get into the juicy shit,
6 minutes
man?
apart. But Scott's additional time circling the planet at high speeds mean he is technically 5 extra milliseconds younger than his twin brother, who has spent more time on Earth. Mark has traveled 5 milliseconds forward in the future from this perspective. Obviously, this is an imperceptible amount of time, but it is really cool to think about. Not only is time travel real, but it's happening whenever someone is in orbit above the planet. The speeds at which our current spacecraft move are nowhere near fast enough to travel a significant amount through time. But this may not always be the case. If you were an astronaut on the first ever spacecraft to travel 99.9999% the speed of light, you would time travel into the future in a significant way. At this speed,
How they did in Buzz Lightyear. How they did in Buzz Lightyear. If y'all ain't seen Buzz Lightyear, that's my bad, but that shit did happen, bro. Bro's going like super light speed and going like 40 years into the future, bro. Fucked his whole life up, bro. Fucked his whole Obviously, he had a happy ending, bro. It's a Disney movie, but he fucked his whole life up, bro. Lost all his friends, bro. Everything, bro. And you wanna play with this shit, bro.
20 hours for you on the Lightspeed spaceship. This means that if you travel just under the speed of light for one day, you would have been speeding along for 86,400 seconds. When you return to Earth and stop moving, you'll have aged only one day, but on Earth, 72,000 days will have gone by. In simpler terms, you would have actually traveled about 197 years into the future. This form of time travel is theoretically possible once the technology exists. However, until then, the primary source of human time travelers will be anyone who orbits the planet at high speeds. Traveling forward in time is the easy part. It's traveling backward that leads to some problems. That being said, you're actually somewhat of a time traveler yourself every time you look at the night sky. Since everything in space is really far away, it takes a long time for the light from stars to reach us here on Earth. That means when you look at stars, you're actually looking back in time at how the star looked hundreds, thousands, or even millions of years in the past. For example, the North Star, also called Polaris, is located in the handle of the Little Dipper or Ursa Minor constellation. Polaris is approximately 323 light years away from where you are standing when you go stargazing. Whenever you see Polaris, you're actually looking 323 years into its past. If Polaris exploded right now, it would not disappear from our night sky for another 323 years. And if you want to time travel a little closer to home, all you need to do is look at the moon. Whenever you observe the moon, you're actually looking into the moon's past by about a second. This is because it takes the light reflected from the moon.
That's what happens on the 4th of July, bro. Because when the fireworks pop, it breaks the sound barrier. You know what I'm saying?
1.3 seconds to reach Earth. So, observing the past isn't so hard, but actually traveling to the past is a whole other animal. One way that someone could travel back in time is by using natural phenomena in space called wormholes. It's hypothesized that these tunnels connect two different points in the universe, but wormholes may not just connect space, they might also connect various points in time as well. To be clear, no wormholes have ever been found, but science seems to think that they are not only possible, but might be more common than we think. When talking about the universe, it's important to remember space and time are closely intertwined. In fact, they are sometimes treated as one variable called space-time. The way a wormhole works is that a massive amount of gravity folds space-time in on itself and connects two points that are incredibly far apart, making traveling between them almost instantaneous. If this is the case, the wormhole might do the same thing to 2 points in time as well. Therefore, if traveling through a wormhole is possible without being crushed by gravity, torn apart by interdimensional turbulence, or being blinked out of existence by some unknown force, time travel may be possible by entering one end of the wormhole and coming out the other.
Yeah, if I want to die, just do that to me, bro. Just blink me out of existence, bro. Please, bro. Come on.
Time travel leaves us with a couple of problems. First and foremost, we haven't found one yet. And second, we have no idea what would happen once inside of the wormhole. However, there is some good news. Scientists have been cooking up other ways to travel through time. One idea is by using what's called a Tipler cylinder, named after the astronomer who proposed it, or an infinite cylinder. Basically, this time machine consists of a very long, indestructible tube. The tube would be filled with matter equal to 10 times the mass of our sun, which would create a very dense, spaghettified black hole. The whole cylinder containing that stretched out black hole would then be spun billions of revolutions per minute. The rotation of the elongated black hole would cause space-time to distort in a way that would allow a ship traveling on a precise trajectory through its ripples could travel back in time and end up in the past. The researchers who are studying this form of time travel have concluded the only way the device would work is if the cylinder was infinitely long or made out of some unknown material that would contain the black hole and allow it for somehow to curve back in on itself. So we're a long way from making the infinite cylinder a reality. This type of time travel would be on a closed time-like curve, meaning that to avoid any sort of paradox, the time travelers who went back in time would have previously existed wherever they ended up. This is incredibly confusing, and science has found no way to explain this phenomenon yet, but the time travelers would somehow need to be part of the past and of the future at the same time. Trippy, right? Another cutting-edge theory in the quest for time travel comes out of the Technion Israel Institute of Technology. It's here that theoretical physicist Amos Ori came up with the idea of making a time machine out of space itself. His vision consists of creating an area in space that's wrapped in on itself like a donut. This would create a donut-shaped vacuum where timelines would collapse in on one another by using gravitational waves to manipulate space-time. Therefore, a time traveler could enter the timeline at one spot and exit at some point in the past. There's also a catch to this type of time machine, however. The time traveler could only travel as far back as to when the time machine was turned on. This is because time would only be able to fold in on itself as far back as the first instance of time within the donut-shaped space vacuum. Another key challenge would be to control the gravitational fields at will. This is theoretically possible, but we are nowhere near to having the technology to do that right now. In order to send someone back in time, they would need to be launched through the vacuum while the gravitational field within it was simultaneously shifted to allow the traveler to loop back in on an earlier point in the timeline. Without that precise control of gravitational waves to manipulate space-time, the donut-shaped time machine wouldn't work. Putting aside those silly technical issues that need to be overcome before time travel is possible, there is another problem that's been plaguing scientists since they first thought of traveling back in time. This is the paradox. When traveling backward in time, all kinds of crazy things can happen. The most famous is the grandfather paradox. It goes like this. If you're a time traveler who goes back in time and kills your grandfather, then would you have never been born? And therefore, could you have never gone back in time to kill your grandfather in the first place? Paradoxes like this have led many scientists to conclude that time travel to the past is impossible, or that if it is possible, the chances of a paradox happening are so likely that it would end the entire universe. But recently, researchers have been looking at these timeline inconsistencies in a new way. It's now hypothesized by some that if a paradox were to occur in the universe, it would fix the problem itself. Take the grandfather paradox, for example. If you went back and killed your grandfather, thus making it impossible for you to be born in the first place, the universe might adjust and you find out the man you killed wasn't really your grandfather at all. Perhaps you were actually adopted and you just never knew. Scientists who believe that paradoxes will naturally correct themselves...
What? That shit make no sense at all, bro. And I know you thinking that too, bro. It would fix itself, bro. What? Bro? Nah.
This allows for time travel to the past without causing the universe to be destroyed by inconsistencies in the timeline. Whether or not it's true, it at least allows scientists to make calculations and theories about time travel to the past. When it comes to time travel, there are some key takeaways. Traveling to the future is theoretically easy. All you need to do is go really fast. Traveling to the past is hard, and it takes some fancy math, a lot of gravity, and technology we don't have yet. Not to mention that if paradoxes don't naturally fix themselves, traveling back in time could end the entire universe. Now watch, did Pan Am Flight 914 really land 37 years later? Or check out the CIA's secret time travel program. Really crazy research?
Alright, bro, so we just found out that time travel is pretty real, bro. That shit's pretty possible, bro. But yeah, that's it for me, man. I hope you have a great rest of your day, bro, and you just go tackle some shit, bro. Be productive and all that type of shit, bro. I'm probably finna go do some dumb shit. I'll probably be streaming tonight, though. So y'all should come tune in. I'll probably be doing some shit to myself every time I die in some game or something like that, or every time I lose or something. So y'all should come tune in and shit. I'll put it in the description. I don't know if I'm gonna make my own Twitch. I'm gonna just do it on the TQTV Twitch, bro. But yeah, anyways, bro. But yeah, man. Appreciate y'all.